Welcome to this tutorial on multi-declarations and component functions in Kotlin. In this video, you'll master componentN functions that enable destructuring support in your Kotlin code. This is an advanced Kotlin feature that makes your code more concise and expressive. Destructuring is a powerful feature that allows you to extract multiple values from an object in a single declaration. For example, if you have a person object, instead of accessing name and age separately, you can destructure them into two variables at once using the syntax val open parenthesis name, comma age close parenthesis equals person. This makes your code cleaner and more readable. When you write a destructuring declaration, Kotlin actually compiles it into something different behind the scenes. What you write as val open parenthesis name, comma age close parenthesis equals person gets compiled into two separate lines. Val name equals person.component1 open close parenthesis, and val age equals person.component2 open close parenthesis. These componentN functions are the foundation of destructuring in Kotlin. Data classes make destructuring incredibly easy because they automatically generate componentN functions for you. When you declare a data class person with name and age properties, Kotlin creates component1 and component2 functions automatically for all primary constructor properties. This means you can immediately destructure any data class instance without writing any additional code. For regular classes that aren't data classes, you need to manually implement componentN functions. Here's an example with a point class. You must define component1 and component2 as operator functions that return the x and y values respectively. The operator keyword is crucial here, as it tells Kotlin these functions can be used for destructuring. Once defined, you can destructure point instances just like data classes. Destructuring isn't limited to simple variable declarations. You can use it in function returns, where a function returns an object and you immediately destructure it. In for loops, you can destructure map entries to get key and value pairs directly. Lambda parameters also support destructuring, allowing you to destructure each element as it's processed. And if you don't need all values, you can use an underscore to ignore unwanted variables during destructuring. There are some important rules to remember when working with componentN functions. First, all componentN functions must be marked with the operator keyword. Second, position matters significantly. Component1 always maps to the first variable, component2 to the second, and so on. Third, data classes only generate componentN functions for properties in the primary constructor, not for properties defined in the class body. Finally, remember that you can use an underscore to skip any values you don't need during destructuring. Let's wrap up with some best practices. First, use data classes whenever possible since they automatically generate componentN functions, saving you time and reducing boilerplate. Second, limit destructuring to a small number of properties, ideally 2 to 3, to keep your code maintainable. Third, always name your destructured variables meaningfully to maintain code readability and make your intentions clear. Finally, consider using destructuring for built-in collection types like map entry, pair, and triple, as they're specifically designed to work well with this feature.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.